So, talking about the bicycle problem with the biker coming down a hill, traveling at a constant velocity. Okay, traveling at a constant velocity. There's no friction. We treat the surfaces as frictionless. With a mass of, I think it's 85 kilograms. We're given that the air resistance on the bicyclist is using the equation of force there, some constant times velocity. Okay? What we need to do in this problem is to be able to calculate what that constant is. Now, the first thing we need to do is come up with a free body diagram, all the forces on that bike. Okay? So talking about all the forces that are on that bike, we have force of normal and air resistance. Okay? So this is normal, weight, and air resistance. Okay? So, talking about Newton's second law, talking about orthogonality, I can make the equation forces in the x equals mass times acceleration in the x. Forces in the y equals mass times acceleration in the y. And I should put x and y. Okay. So, because I have two vectors already perpendicular to each other, it seems to me that the best way to describe my coordinate system is to say this way is the x, and this way is the y. Okay? Cool? So y this way, x this way. Forces in the x. Talking about all the forces in the x. It's the important ones. Okay? In this problem, we only really have to concentrate about forces in the x. Not forces in the y because we're not dealing with the force of friction. Okay? So forces in the x. Well, the first force I have in the x, let me use this chalk, is air resistance. Now the air resistance equation is given as some times, I'm going to put a vector over there so that we know that these are for velocity. Okay? That's one, and then we can say that for 1 second, is negative. Okay? There's also a portion of my weight in that direction. Okay? So there's my weight in this direction, but there's a portion of it that's in the y, and then there's a portion of it that's in the x. Well, that angle and this angle are the exact same values. So to determine what this is, well, that's mg, the hypotenuse of that triangle, times the sine of theta. Okay? So I can say that my forces in the x is going to be the air resistance plus mg sine theta. There's no acceleration, so this term goes to 0, and I'm left with 0 is equal to the coefficient times the velocity. Sorry, excuse me for 1 second. Minus the coefficient times the velocity plus m. So I'm left with, hope it's not coming up because I forgot to put lines this morning. I'm going to erase this section of it. So I can write it over here. Grab my paper towel. Okay. So I'm left with negative CV plus mg sine theta is equal to 0. Okay? And I'm trying to solve for the coefficient. So the next thing I'm going to do is isolate that coefficient. I'm going to move the mg sine theta over to the other side. So I'm left with negative CV equals negative mg sine theta. Okay? Solving for C, I cross off my negative signs because they're on both sides, and I'm left with C is equal to mg sine theta divided by Okay? So to solve for the coefficient of error, what you're going to end up with is the portion of the weight down the incline divided by the velocity in which the bike is traveling. Okay? Now, this is only one possible equation that you can end up with when dealing with air resistance. So don't necessarily buy that this CV is always going to be the equation for air resistance.